Okay, so back in section 10.1, we talked about the Alabama paradox, which happened with Hamilton. In this chapter, we're going to talk about a couple other paradoxes, and the first one is called the population paradox. And that will occur when state A's population is growing faster than state B's, yet A loses a representative to state B. And this is a situation where assuming that the total number of representatives in the legislature is not changing. So for an example of this, here we go. All right, a university used Hamilton's method to apportion 15 graduate assistantships among the colleges of education, liberal arts, and business based on undergraduate enrollments as shown in the table on the next slide. So, okay, part A. After the allocation was made, the education department gained 30 new students. Liberal arts gained 46, but business stayed the same. They want you to reapportion the graduate assistants. And then after you do that, explain how this illustrates the population paradox. All right, so here's a chart. And again, they were using Hamilton. And remember that, I don't know why they're doing it this way, but they got this standard divisor thing using Hamilton's original method. So they just went ahead and used the standard divisor and then used his fractional part. The math comes out the same, even if you took, let's see, for the education majors, before you would take the total number of education majors and divide it by the total number of students in the school, and then multiply that times the 15 assistantships. But doing it this way would end up resulting in the same number. So it's okay. Oh, well, it would be this number here. That number. Okay, it's going to give you the same number. So don't worry about it. It works out. And then, of course, Hamilton always gave them the whole number part, right? So there's the 3. And then he did this one. There's the 5. And there's the 5. But that only adds up to 13. And that means there's 2 more assistantships. So then Hamilton went back and he said, well, you got 0.5552, 0.50, and 0.99. So this is the biggest and this is the second biggest. So he added 1 here and 1 here, and that gave him 4. And this one became 5 and 1 is 6. And this one just stayed at 5, and that added up to the 15. Okay, so that was how Hamilton did it. And that was the original situation. Well, what happens next is the Department of Education, which was my yellow here, and then the liberal arts gained more students. So education gained 30 more. They're showing 30 more. Whoops, need a highlighter. They gained 30 more students, so now it's 970. And then liberal arts gained 46, so now that's that. But business stayed the same. So the new total of undergraduate students, they added them all up now, which would be the 970, 1,516, and the 1,600. This would be your total. And then they went ahead and used the standard divisor thing again, but that is no different than taking like 970 divided by the total number of students, which is 4,086, and then multiplying it times 15. It's going to work out the same. You're still going to get this number here, 3.56. If you don't believe me, do it. You'll find it's the same. So anyway, they do all this stuff here with the standard divisors. They take the total number of education students and divide it by the what color should I use over here? I don't know. How about bright pink? Divide it by the standard divisor. That's the denominators that you see on all of these. 272.4, 272.4, 272.4. But then you're going to have the numerator for liberal arts is the 1,516. And I haven't done business yet, but how about Baloo for them? 1,600. Okay, which then gives you the standard quota numbers. And what he did is he said, okay, this is Hamilton again. There's the whole number 3. There's the 3. Whole number 5. There's the 5. Whole number 5. There's the 5. 3 and 5 and 5 only adds up to 13. There's 15. But this time, when he goes back and he looks at the fractional part, 0.87 is the biggest and 0.57 is the next biggest. So now this one gets a 1 and this one gets a 1, which leaves you to 6 and 6. And this one up here is still only 3. Ooh. So what you can see is, okay, the education students increased. They increased by 30 out of the original number of 940. We're doing a percent increase. Remember, when you take the new minus the old and divide it by the old, well, new minus old would be how many new students you have, which is 330. Divide that by 940, and then they get 0.0319, which in percent land is 3.19%. Then they did the same thing with liberal arts. There were 46 new students. That's what you'd get from calculating new minus old, how many new students there were, divided by the original number of students, gave you this decimal, and in percent form, it's 3.13. So you can see that education is actually increasing at a faster rate. Their rate is 3.19%, where the liberal arts students are only increasing at 3.13. And business, they didn't grow at all. They didn't grow at all. But even though the College of Liberal Arts grew, this is what it's saying down here, even though the College of Liberal Arts grew more slowly than the College of Education, it was still able to take away one of education's GA students. And this is what they call the population paradox. It happens. Crap happens all the time. Which brings me to the new states paradox, and I will do that in a separate video.